In this video, we're going to start doing some math with polynomials. Polynomials are expressions that have more than one term. So we have binomials and trinomials, and then when it gets bigger than that, we just group them all together as polynomials, many termed expressions. So how do we do math? How do we add polynomials, and how do we subtract? If we got some time today, we'll go over multiplying as well. So first, there's two different ways that we can do it. Let's just get a polynomial going here. Minus x minus 7. If we wanted to add that to a polynomial like x to the third minus 10x squared plus 8. Here's one way we can do it. We can stack them vertically here and just add just like you would normally add things. The only trick here is to make sure that you're combining like terms. So they have to have the same power, first of all. So that's one way to do it. If you're missing a power, like we don't have an x term here, an x to the first power, you can replace that if you want, or you can leave it blank. And then let's just stack them and combine them. So negative 7 plus 8 gives us a positive 1. Negative 1x plus 0x is negative 1x. 2x squared minus 10x squared is negative 8x squared. And 3x squared plus 3x cubed plus 1x cubed is 4x cubed. So adding these two polynomials, we get 4x cubed minus 8x squared minus 1x plus 1. That's our final answer. Let's try another one. 9x cubed minus 2x plus 1. 5x squared plus 12x minus 4. So here we got two polynomials. We can group them together with parentheses, that's okay. Again, let's try and add them. So here I haven't stacked them. If you see a problem where you have to add polynomials and it's just a horizontal layout here, one thing you can do is kind of just draw arrows connecting your like terms. So we don't have any other x cubes, so we'll just drop that down. 9x cubed. We don't have any other x squares, so we'll drop that down. And we do have x to the first power. So I always just like to kind of connect them with a line if you need to, or you can just think in your head, visualize it. So we got negative 2x and positive 12x. That's a positive 10x. And a 1 and a negative 4 would give us a negative 3. So two different ways. You can stack them vertically, or you can keep them in a horizontal position and just combine like terms. I mean, that's essentially what we're doing. So subtracting is not much trickier. Let's get a problem going here. And if I want to subtract 2x cubed plus 6x squared minus x plus 1. Again, we can do it vertically or horizontally. We'll do it vertically for the first time here. The one thing that you got to be careful of when subtracting polynomials is that we're subtracting this whole expression here. So it's kind of like we have a negative 1 on the outside of parentheses, and we need to distribute that negative 1 all the way through to each term. So we make each term the opposite sign of what it is. And then we can just add them. So if I distribute my negative 1, I get a negative 2x cubed. I get a negative 6x squared. I get a positive x. And I get a negative 1. And now I'm just combining, just like addition. So 8x cubed minus 2x cubed gives me 6x cubed. Negative 3x squared and negative 6x squared is negative 9x squared. Negative 2x and positive 1x is negative 1x. And a positive 9 and a negative 1 gives me positive 8. Okay, so that's our final polynomial when we subtract those two. So yeah, just be careful when you're subtracting. Make sure that you distribute that negative to every term in your polynomial. That's really the hardest part about it. It's nice to be able to add and subtract polynomials, and we'll see why this is useful when we get to dividing them, which we'll get to in a couple of videos from now. Let's get to multiplication. We got plenty of time. Negative x squared plus 2x plus 4. Here's a unique way to multiply polynomials. We can do it vertically again. It's kind of just like our old school multiplying back in grade school. This is a multiplication, not an x. So we're multiplying these polynomials. What we do is we take the negative 3, the first term, and we multiply it by everything in our top. So negative 3 times 4, negative 12. Negative 3 times 2x is negative 6x. And negative 3 times negative x squared is a positive 3x squared. And just like in the old school, grade school multiplying, we got a little place value here when we're done with our 1 units. We could put a 0 there, we can leave it blank, you can put x's. You just need a placeholder there saying that, reminding you not to put anything there. Alright, let's move on to the next term. So now we're multiplying x by all of our terms up top. X times 4 is 4x. X times 2x is 2x squared. That was a positive 4x. And x times negative x squared is negative x cubed. So now we go back to what we were just practicing, combining or adding our polynomials. So we're adding these polynomials. So negative 12 plus 0 is negative 12. Negative 6x plus 4 is a negative 2x. 3x squared plus 2x squared is 5x squared. And we got that negative x cubed being added to nothing over there. So there's our final product, multiplying those two polynomials. We can also multiply polynomials using our distribution technique, which is something you're probably more familiar with at this level. If we got x minus 3 times 3x squared minus 2x minus 4. You can do it horizontally as well and distribute. You can either multiply everything by negative 3 first and then multiply everything by x, or you can multiply everything by x and then negative 3. I like to go left to right, so let's multiply everything by x first. X times 3x squared is 3x cubed. X times negative 2x is negative 2x squared. And x times negative 4 is negative 4x. And we're going to combine that with our next row of products here. So negative 3 times 3x squared is negative 9x squared. Oops. I want to make sure and line up our like terms, stack them, and just makes adding or combining a lot easier. So since I'm dealing with an x squared, I would want to put that underneath my x squared. Negative 3 times negative 2x is negative 6x. Sorry, positive. Negative times a negative. Wow, I'm slipping right now. Let's get it together. Negative 3 times negative 4 is positive 12. Okay, so now we're combining our terms here. We get a positive 12, a positive 2x, a negative 11x squared, and a positive 3x cubed. And so that's our last product when we multiply the polynomials. Real quick, let's talk about mostly a little bit of review. Thinking back to when we factored and having our special factor patterns, well, now we're basically working backwards starting with the binomials being multiplied and going back to their original polynomial form. So if you remember something like that, you could distribute, FOIL it out, and get your answer. But if you recognize that this is our difference of squares pattern, remembering that our middle terms are going to cancel and we're just going to be left with the product of the first and last terms, it's a little quicker. You save yourself some time. So we know we're going to end up with 4n times 4n, that's 16n squared, and it's going to be minus the product of the last terms, 25. So this is a difference of squares. We would factor it to get that, and we would distribute to get back to there. This is basically just a little wheel that we could turn over and over and over again. Okay, so again, just recognizing those patterns saves you a lot of time. There's another pattern here. 9y minus x squared, let's say. So squaring a binomial. If you remember that this came from a perfect square polynomial, or perfect square trinomial, then again, I mean, we could rewrite this as 9y minus x squared times itself, 9y minus x squared, and FOIL or distribute to get to the end. Or we could recognize that this is a perfect square, and we could jump to the end if we remember that. So it's always that the first term squared, so 81y squared. We know it's the last term squared over here, x to the fourth. And what was in the middle was where it's twice the product of our roots here. So 9y times x squared would give us 9yx squared, or alphabetically 9x squared y, and it's twice that product. So our middle term is going to be 18x squared y. And we know that the last term is always positive, and this middle term gets the sign that came from there. So we end up with that. So again, you could FOIL this out and get to the same thing, but if you remember your patterns, it just saves you some time. The last pattern here, this is brand new. Since you've never seen a cube of a binomial before, this is the pattern that you follow. Anytime you have two terms, a binomial being cubed, you always get this. You always get that first term cubed plus 3, and it's always going to be 3 right there, 3a squared b plus 3ab squared plus b cubed. You'll always get this pattern. Let's do one more here. This is a different pattern. So here is a sum, and here is a difference of two terms. Slightly different pattern. Still have a cubed, but now we have minus 3a squared b plus ab squared minus b cubed. So just slight difference in the signs at the beginning and at the end. But basically those are your patterns. We don't have enough time in this video to do any examples, so I'll just start our next video doing examples of cubing binomials in these two different forms. And yeah, see you there.